Chalo. Namaskar everybody. Good afternoon all. I welcome you all on the behalf of StudyIQ IS. My name is Pritesh Maturkar. I am the Senior Faculty of Geography, Environment and Ecology in StudyIQ IS. So guys, I welcome you all to session number 2 of Success in Prelims module, where we are targeting the PYQs, and alongside that we are also trying to basically understand and appreciate as to what trends you should follow. So today being now the second lecture, I will be zoning on some of the important aspects. So in today's session, we'll be understanding like how to target the most important chapter of geography, which is climatology. So when I'm talking about climatology, guys, this is a very important chapter. And if you see the past 2 years trends in climatology, these trends are little bit frightening. Frightening in what sense? The conceptual clarity what is needed is really very important. So in today's session, what I'm trying to do for each and every one of you is that I'll be breaking down climatology into two parts. In the sense of what? That first of all, we'll understand the surface conditions. Surface conditions meaning that if we are talking about winds, if we are talking about basically the atmosphere, so till basically around, let's say, first 50 kilometers, how is the atmosphere stratified, how is the atmosphere structured, and if I'm talking about winds, so we'll be targeting about the surface winds. We'll also target little bit with respect to something referred to as basically the pressure and temperature patterns. So the significance of atmosphere till first 50 kilometers, winds till basically the troposphere out there, because that is referred to as the weather layer. And then in the next session out there, we'll be targeting the aloft conditions. Aloft conditions meaning that we will be targeting something called as jet streams, Rossby waves. Then we will target something called as air masses. So air masses also tend to extend for the entire height of troposphere. So what we are trying to do is now is that we'll be breaking down the syllabus. We'll be understanding the questions of the past 2 years, 2024 and 2025, from this particular part today, wherein we'll try to understand how the questions are being framed from the part which is referred to as the structure and composition of atmosphere, the heat balance of earth, the pressure and the temperature patterns that we have on earth at this very movement. Okay, so let us start understanding. Good evening, Kanwar ma'am, hope you are fine. Rest of you, those who are watching me live right now, feel free to comment, because this being a live lecture, I will be taking your doubts and I will be making you understand all the different stuff out there. So when I'm talking about now climatology, right, so we need to remember that what is the pedagogy of it. Pedagogy in the sense, if we really want to understand the climate of a place, what different parameters we need to understand foremost out there. So first of all, let me open up some of the questions for you of the past 2 years, and then we will have a generalized understanding. So this is this year's paper, 2025's papers, basically questions out there. So question number 1, scientific studies suggest that a shift is taking place in the earth's rotation and its axis. Then statement number 2, solar flares and associated coronal mass ejections bombarded the Earth's atmosphere with a tremendous amount of energy. As the Earth's polar ice cap melts, the water tends to move towards the equator. So now this question, statement number 2, is in very much in news. Sir, suggest a book for geography. Book beta, Dinesh ji, you have asked a very generic question. The only book I can suggest is 11th NCRT and GC Leon Part 2, chapter number 15 till chapter number 25. Rest, please follow newspaper, please follow economic survey and budget. So these are the most ideal sources for covering geography, right? So when I'm talking about this statement number 2, this statement number 2 is in very much news. Why? Because Airbus has basically ordered its global fleet of A320s to basically update their software. Because this year you were having a solar maxima coming, the coronal mass ejection peaked, and because of that, the data of the aircraft got basically corrupted because of high intensity of solar flares. So now if you talk about this question, so this question can only be answered if you have a detailed knowledge about the structure and composition of the atmosphere out there. Then if I take you to question number this one, question number 5. The amount of dust particles in the atmosphere is more in the subtropical and temperate areas rather than in the equatorial and the polar regions. Statement number 2. Subtropical and temperate areas have less dry winds. So, which of this is correct? The amount of dust particles in the tropical and the subtropical areas is more than the equatorial. Is this statement correct? The answer is yes. Why? Because this is the subtropical high pressure belt. So if we are talking about the subtropical high pressure belt, the air is little bit subdued. So when the air is subdued, the air tends to get saturated with what? With dust particles. Therefore, the scattering of light is even more. And if I'm talking about subtropical and temperate areas have less dry winds, this statement is not correct. Why this statement is not correct? It does not have less dry winds, rather it has more dry winds, because as we move up, the precipitation from equator towards the poles, it starts decreasing. So when I'm talking about dry winds, the temperate and the subtropical areas out there, these are the areas having subtropical high pressure belt. High pressure belt meaning that you will be having intense solar radiation. Solar radiation meaning the insolation amount and intensity will be good enough, particularly in the subtropical areas wherein we have majority of the deserts, and in temperate areas, these areas they will be having 300 days of summer and only 60 days of winter rains, the Mediterranean type of climate. So again, when I'm talking about this question will require you a good understanding of temperature and pressure patterns out there and also the different climates of the world. See, answering PYQs is very easy only when you know the concepts and from where to actually target it. Now, if I talk about the next question, in January, the northern hemisphere, the isotherms bend equatorwards while crossing the land masses and polewards while crossing the oceans. And statement 2, in January, the air over the oceans is warmer than the air over the land masses in the northern hemisphere. So, which of these statement is correct? Both the statements are correct, and statement 2 correctly explains statement 1. Now, to answer this question, you need to know the concept of specific heat. You need to know the concept of shifting up of isotherms as we move from land towards the water and from land and from water towards the land out there. So again, if you talk about this question is again based on conceptual clarity. Such questions can only be answered if your content is to the point and your concepts are astute. So please make sure that you understand and appreciate it, and I will be teaching you as to how to talk about this. Then let me talk about one more question. See, consider the following statements. Without atmosphere, temperature would be well below freezing point everywhere on the Earth's surface. Heat absorbed and trapped by the atmosphere maintains our Earth's average temperature. Atmospheric gases like CO2 are particularly good at absorbing and trapping the radiation. Now, this concept is based on what? This concept is based on understanding how the average ambient temperature of the earth is maintained. This is the concept of what? This is the concept of greenhouse gas effect. So, this concept is correlated with the normal lapse rate concept in the troposphere. So, here all the statements are correct. The correct answer is statement number C. Then the next question, which we discussed in the last class, wet bulb temperature routinely exceeding 35 degrees Celsius. How does it impact the life? So if you see these 4 to 5 questions, these are based on only one part of climatology, which is the structure and composition of atmosphere, understanding the temperature patterns and the pressure patterns resulting into winds. Then if I take you to one more question of this year only, to 2025. So see this particular question, I guess it's over here or not. No, it's not here, it's in 2024 out here. So this is the paper of 2024, and in this paper, if I open up this question, Yeah. So see, the atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. So, do you see the similarity between this year's question and last year's question? Those who are watching me live right now, see, that is why the analysis of PYQ is so quantum important, because you understand which part is UPSC targeting. So we are now living in the era of climate change induced global warming. No, we are living in the era of global warming induced climate change. Aren't the two questions almost similar? So that is why I'm telling you all, since my first lecture, please focus on concepts. Concepts are very, very important. Then see this question. The thickness of the troposphere at the equator is much greater as compared to that at the poles. At the equator, the heat is transported to greater heights by strong conventional currents. Again, question on structure and composition of atmosphere, and both of the statements are correct. Then, if I talk about another question out here, so understand this question too. The isotherms deviate to the north over the ocean and to the south over the continent. The presence of cold ocean currents, Gulf Stream and North Atlantic drift make the North Atlantic Ocean colder, and the isotherms bend towards the north. Are you seeing the similarity between the questions which is being framed? Now, this is the amalgamation of climatology and the amalgamation of the oceanography out there. But see, again, same type of questions being framed, meaning that if you target the PYQs appropriately, you will be able to predict what sort of questions can be expected next year. Then, one more question out there. Rainfall is one of the reasons for weathering of rocks. Rainwater contains carbon dioxide in solution. Rainwater contains atmospheric oxygen. So, rainfall is one of the reasons for weathering of the rocks. Is this statement correct? And if you see, both statement 2 and 3 are correct, but only one of them explains statement 1. Only one of the statement 2 and 3 is correct, but only one explains statement 1. No, the correct answer is both statement 2 and 3 are correct. So this is correct, and both of them explain statement 1, because both of this will result into what? Will result into denudation and weathering of the rocks out there. So chemical weathering, chemical erosion out there. So for this, you need to understand the concept of precipitation. You need to understand the concept of basically erosion and the associated condensation of the rainwater. So now what we have to do is, if you really want to have good marks in climatology, so first of all, we need to understand how to target climatology, because the questions are rather very easy. If you get these questions wrong, if you get such kind of questions wrong, then it's a big blunder. Blunder in what way? Because everybody, those who have practiced the questions properly, they will be able to answer these questions without any fuss, and they will be not wasting their time on thinking such questions, rather they will give more time to tricky questions out there. So targeting climatology is very, very important. So if we really want to target climatology, we need to first understand what to read and how to proceed. See, when I'm talking about climatology, first of all, we need to understand what is climate, right? So if I'm talking about climate, what climate of a place really entails? So climate of a place is something which is referred to as long-term average. Long-term average in the sense that for approximately 28 to 30 years, the weather of that particular place will be averaged out. The weather of that place will be averaged out there. Now, what do you mean by weather? See, whenever you call a friend out there, you will always ask how's the weather. You will never ask how's the climate, because climate is what we expect and weather is what we get. So weather is the day-to-day conditions, weather is the day-to-day interplay of what? Weather is the day-to-day interplay of what? So interplay of parameters. What parameters out there? So we have the parameters temperature, then we have pressure, and lastly we have something called as humidity. Then where will this temperature, pressure and humidity vary? Where will they show variations? So the variations will be shown in the air, and air is nothing but what? Air is nothing but the atmosphere out there. So, in order to understand climatology, your pedagogy or your methodology should be such that first of all you understand what is atmosphere, what is its structure, what is its composition, then you understand the variations of temperature and pressure. So, variations in temperature will give you the knowledge with respect to the factors responsible for basically the variations to like altitude, like ocean currents. Pressure patterns will help you understand the winds on earth. Humidity will help you understand the concepts of condensation and precipitation. Then once you understand this, you will be able to decode the weather of different places. Like how does the weather of the northwest Europe differ from the weather of basically central India? How does the weather of savannah differ from the weather of the Arctic? What parameters do you think vary out there? And once we understand the weather, then we'll be able to appreciate climate, and ultimately then only we'll be able to understand climate change. We'll be able to understand what? We'll be able to understand climate change. See, many times, or rather I say maximum aspirants commit this mistake that they just solve PYQ without focusing on from which part are they being framed and what is the importance of that part and what questions can be framed in the future. It is only when you understand that yes, the questions can be framed like this and the level with which the questions are being framed, then only you'll be able to score good marks in the coming attempt. So now let us move and let us try to decode the questions which can be framed from this part, supposedly the structure and the composition of the atmosphere. Okay, so now if I'm talking about structure and composition of the atmosphere out there, in the past 2 years I've shown you, but if I compare the questions of the past 5 years, the questions are more or so on the same line. If you really know the good intricacies, if you really know the good basic points, then you will be able to clearly understand how things are asked. So when I'm talking about structure slash composition, considering the UPSC civil services perspective, you need to know three parameters. Number one, you need to know the application of concepts. We need to know what? We need to know the application of concepts. Where and how whatever we'll study will vary in the world, then we need to know the requisite current affairs. So I will give you good examples as we take today's lecture, and then last but not the least, we will try to understand the locational analysis too. We'll try to understand the locational analysis. So if we are trying to understand the application of concepts, so let us start off with the very first concept. Let us try to understand the composition. So if I'm talking about the composition of atmosphere out there, so what is the composition? So in composition, number one, we have the major gases of the atmosphere. So the major gases, they are also referred to as the permanent gases, right? Number two component, we have the minor gases. We also refer to them as the temporary gases. Then we also have water vapor, and we have something referred to as the dust particle. So dust particles or basically the aerosols out there, right? So what is needed from civil service perspective is that if you are talking about the major gases, what is the role of those gases? Because unless and until we understand what one particular gas does for Earth, what one particular gas does for life on Earth, it will be absolute chaos not to focus on the exact part and focusing only on the PYQ. So when I'm talking about major gases, the first major gas out there is nitrogen. Nitrogen is close to 78%. Then we have oxygen, it is close to 21%. Then we have argon. Argon is barely 0.93%. And if I'm talking about CO2, how much is CO2? Can anybody guess? If I'm making you understand, if I'm stepping outside the frame, can anybody tell me what is the percentage of CO2 that we have in the atmosphere? Anyone? So the percentage of CO2 is barely 0.03%. And mind you, when I'm talking about these percentages, this is percentage volume of which air? This is percentage volume of dry air, right? This is percentage volume of what? This is percentage volume of dry air out there. It's yes. Very good, Satish. When I'm talking about minor slash temporary gases, so they will not be present everywhere. The first minor slash temporary gas, we have ozone. Ozone is 0.00004%. And then we have helium and we have xenon. Now, if I'm talking about water vapor will be around 0%, where in the subtropical hot deserts, right? And if I'm talking about the equatorial rainforest, so the air will be saturated close to 4 to 5%, right? And lastly, if I'm talking about dust particles slash aerosols, they will completely depend on what? They will completely dependent on anthropogenic activities. Anthropogenic activities meaning that when I'm talking about the dust particles and aerosols, the more the level of industrialization, the more the level of urbanization, the more these gases, the more the particulate matter PM 2.5, PM 10 will be more concentrated. So more PM 2.5, PM 2.10, sorry, PM 10, meaning the more the diffusion, the more the scattering of the atmospheric light, the more the scattering of the sun's rays. So more the scattering, even during the winter times, so the temperatures will start to fall. The temperatures start to fall, meaning the air surrounding the land surface becomes very cold. We experience temperature inversion, and that is why the AQI starts falling in the sense it moves into severe, very unhealthy and hazardous category out there. So now for civil services perspective, we need to understand, guys, the role of these gases, because this is where the questions are being framed. Now if I'm talking about nitrogen, 78%. If I'm talking about xenon, helium, so and argon, what do these gases exactly do? Can any one of you tell me? Like, what's the role of this? I know that nitrogen is helpful in nitrogen fixation. The plants do require nitrogen, right? But 78% is nitrogen needed by the living beings out there. Do we need nitrogen? We do require nitrogen, but not in the same form as plants require. But what is nitrogen doing? 78%, because the main harbinger of life is 21%. Yes, any one of you can care to elaborate why do we need this? Yes, anyone? See, when I'm talking about nitrogen, argon, helium, and xenon, these gases are so goddamn important. Why? Because in atmosphere we are having O2. O2 is which gas? O2 is a combustible gas. If I'm talking about oxygen, so oxygen is a gas which aids combustion. Is it combustible on its own? No. It basically aids combustion. So if you go to a campfire, if you go to a campsite and if you lit bonfire over there, and if you blow into that bonfire, the fire explodes even further, right? So the atmosphere is bombarded by the sun's insolation. The amount of insolation which we receive, it is basically approximately 1360 watt per meter square. Yes, Kanwar ma'am, you are right. So when I'm talking about oxygen out there, oxygen has the propensity to aid the combustion and the atmosphere can burn on its own. So if the atmosphere is capable of burning on its own, we require someone to dilute it. So nitrogen, argon and helium and xenon, these will all do what? These will all help in basically dilution of the atmosphere. They will help dilute the atmosphere so that the atmosphere does not burn on its own. Now, if I'm talking about the role of greenhouse gases, if I'm talking about the role of CO2, so we now know that the average ambient temperature of Earth is around, like, if I'm talking about the role of basically the major gases. So the role of major gases, basically like nitrogen, like argon, it is basically dilution, right? The role of oxygen, it is basically that it's a life supporting gas. It's a life supporting gas. But do these gas play any role in trapping the heat? Are these gases capable of trapping the heat? No. If I'm talking about the major gases, they are not capable of trapping heat. So if they are not capable of trapping heat, then how is the maintenance of average ambient temperature of the earth done? So if I'm talking about how is the average ambient temperature of earth maintained, so the average ambient temperature of the earth is maintained by whom? It is maintained by greenhouse gases. It is maintained by greenhouse substances. Now if you see in this chart, which are the greenhouse gases, which are the greenhouse substances out there? So the greenhouse gases and the greenhouse substances we have are ozone, we have CO2. If you see their proportion, if you see their combined proportion, it is less than 0.1%. It is less than how much? It is less than 0.1%, right? So in a nutshell, the greenhouse gases, the greenhouse substances, they make less than 0.1% of the atmosphere. And right now, what is the average ambient temperature of Earth? If I just do a quick Google search for each and every one of you. So see this. So the average ambient temperature of Earth is close to how much? Is about 15 degrees Celsius. Right. So if we go by the good estimates out there, it is around 15.1 degrees Celsius. Now, if you see basically the graph out there, yes, not the latest data out there, but still we are able to decode it. I'm just opening up this. Will it be fine? Yes. I guess this is even better. Let me just open up this image. This will help you in understanding basically what has happened. So now if you see the global average ambient temperature, so this is from 1940 till 2023. We have one more chart to go out there. So from 1940 till 2023, if you see the variations, each line over here represents a year. So this is basically the median house temperature from January till December. So from 1940 till 2023, you are seeing what? You are seeing that the average ambient temperature globally is rising. If you average out, the average is close to 15 degrees Celsius. Prior, the average was around how much? Prior, the average was around 13.5 degrees Celsius. Now, the average is close to 15 degrees Celsius. So, on an average, if I'm talking about how much the earth has warmed in the last 100 to 150 years, so in the last 100 to 150 years, earth has warmed by roughly 1.5 degrees Celsius. The average hottest has been taken on 17.08 degree. This has been charted in 2024 itself. In 2024 itself, the hottest day has been, like, if I talk about what is the hottest in 2024, so let me just give you the latest data out there so that all of you can appreciate it. So see, this is basically the data of 2024, right? Let me open up. This is a very good image out there. So this is July 2023 and this is June 2024. So globally now the average has peaked by 1.5 degrees Celsius since when? Since the pre-industrial average 1850 to 1900. So this is 1940s, and now if you are talking about 2020-24, the global average has peaked by around how much? By around 1.5 degrees Celsius. So who is maintaining this? Is basically the major role played by the major gases of the atmosphere. The answer is no. The gases which account for less than 0.1% of the atmosphere are maintaining the average ambient temperature right now of around 15.1 degrees Celsius. If I reduce 150 years back, so this was, let's say, around 13.5 degrees Celsius. So now, why this increase? According to basically the Paris Climate Treaty, we were supposed to do this. We were supposed to achieve the 1.5 degrees Celsius mark by 2050, and we were ambitious that by 2100 we'll be able to stop the global average ambient temperature rise by 2 degrees Celsius. 1.5 was really an ambitious target, but we were targeting that we'll do that till 2050. Now 25 years, still more to go. The world has crossed its threshold. So when I'm talking about these gases, the CO2, then oxygen, ozone. So are these gases really themselves so capable to capture the heat? The answer is no. Now the global average ambient temperature is increasing not only because of carbon dioxide, but if I mark up these areas, this particular area, this particular area, this particular area, this area, this area, and supposedly this area too. And also we can target little bit this area. So see, these are some of the areas, like if I'm talking about India, we can include the northern plains too. So these areas in the world today are those areas where we are having intensive agriculture slash animal rearing. So the grasslands of the world is where we have very high intensity of cattle rearing going on, right? If I'm talking about these areas, again the Ukrainian steppes, this is also very much famous for cattle ranching. Brazil, Argentina, these areas are also famous for ranching. Ranching means the rearing of cattle for beef and beef exports. If I'm talking about India, Southeast Asia, this complete sphere out there, so this is known for paddy cultivation. And the same thing happening in Australia, New Zealand, cattle ranching. If I'm taking you to this area, this is where we have cocoa pod cultivation, and this area, this is where we are having the palm pod cultivation, right? So now, according to UNFCCC's report, internal assessment report, one third of global emissions, they are coming because of what? They are coming because of shifting dietary preferences. One third of global carbon emissions and methane emissions too. See, methane is a very deadly greenhouse gas. The GWP means global warming potential of methane is roughly 5 times that of carbon dioxide, though its life in the atmosphere is less, but its global warming potential is roughly 5 times more than CO2. That not why every cattle area has grown alfalfa grass. Yes, alfalfa grass is the main basically culprit, because alfalfa grass helps to fatten the cattle very quickly. But when I'm talking about cattle ranching, when I'm talking about paddy cultivation, so cattle ranching, you all know bovine animals. The bovine animals, they will do what? The bovine animals, they will basically do mulching. Mulching meanings whenever they will first gut the food, and when the food is, when their stomach is full, they will sit and they'll bring it back and they'll start chewing it properly. So in this process, methane is released. But now, are these gases the most potent gases which are now causing global warming? The question, FYQ. So now FYQ question can come for all of you. Which is the most potent greenhouse gas today? Which gas has the maximum propensity to cause global warming considering 21st century? So now India, China, USA, Southeast Asia, especially Vietnam, Thailand, Cambodia, these countries, they have now aggravated basically semiconductor manufacturing. So if I'm talking about semiconductor manufacturing, if I'm talking about the production of rare earth minerals out there, one particular gas is released which is 32,000 times more powerful than CO2. The global warming potential of this gas is 32,000 times more than that of basically the carbon dioxide. And what is that gas? Sulfur hexafluoride, SF6. So now, when I'm talking about the maintenance of global average ambient temperature, the global average ambient temperature is going on a tailspin not only because of CO2, not only because of methane, not only because of water vapor, not only because of CFCs, HF6, but now the gases like this, which are now the deadly threat of 21st century. See, the electronics industry, the semiconductor industry, it all picked up in the 1990s, right? When the transistors started to go on the nanometer scale. Today we are having 2 nanometer technology. In the future, it can go beyond that also. So when I'm talking about this industry is regulated. We are talking about electric vehicles. Now, when I'm talking about electric vehicles, the manufacturing of batteries, lithium, cobalt. So when the batteries are manufactured again, when you have to insulate the batteries out there, this gas is again released. So we have to be very, very careful with respect to these greenhouse gases. Why? Because these greenhouse gases, they are trapping which heat? They are trapping the Earth's terrestrial heat. Terrestrial heat meaning, see, no gas in the atmosphere is capable of trapping the heat. Then what actually heats up the atmosphere? The answer to this is really very simple. If I'm talking about the heating of the atmosphere out there, so see, this is the Earth, right? The energy which comes from the sun is in which form? So you will say the energy coming from the sun is in the form of electromagnetic radiation, right? EMR. But if I'm talking about EMR, which parts of EMR? So we have gamma rays, we have X-rays, then we have ultraviolet, then we have the visible spectrum. right? After that, we have the infrared, we have the microwave, and then lastly, we are having the radio waves out there. So these are not having enough energy. Gamma rays and X-rays, they have very high energy intensity field. They're primarily absorbed by what? They're primarily absorbed by the electromagnetic field of Earth, because all of us know that Earth behaves like a giant magnet out there. When I'm talking about ultraviolet rays, so the ultraviolet rays, they are predominantly absorbed by what? They're predominantly absorbed by stratospheric ozone. And if I'm talking about the visible spectrum means PYQs. So violet, indigo, blue, green, yellow, orange and red between zero point 0.4 to zero point 0.7 microns. So this is basically the visible spectrum. So you are able to see that I'm wearing this blue color, this is black color, this is white color. Why? Because the atmosphere in between me and this camera lens is able to capture all of this, right? So when I'm talking about these white light, the light from the sun is white. We see different colors because the atmosphere is actually scattering it. So when I'm talking about this light out there, visible light, the atmosphere is largely transparent to it. There is no gas in the atmosphere to actually absorb it. So the insolation which reaches the earth, it is referred to as the visible spectrum. The rainbow colors out there. So this visible spectrum is high energy, but the wavelength is less. This is high energy but less wavelength. This is basically short wave. Right? Now what happens is that this light reaches the earth. Earth will do what? Earth will basically work upon it. And to this, now if we are pumping more CO2, if we are pumping in more methane, if we are pumping more carbon monoxide, if we are pumping more sulfur dioxide, if we are pumping more and more nitrous gases, if we are pumping more and more SF6, so what is going to happen is, when the earth basically works upon it and the earth releases its terrestrial radiation, so this is basically outgoing terrestrial radiation. This is outgoing terrestrial radiation, right? So this outgoing terrestrial radiation is in the form of which wave? Is in the form of infrared. So this infrared now will be absorbed by all of these gases. So more the gases we emit, more will be the trapping of the heat by these greenhouse gas and substances. More the heat traps, more will be global boiling, and more the global boiling. Now the question comes here. The question comes here. So recently you saw a cyclone originating in between Malaysia and Indonesia in the Strait of Malacca. The cyclone which you saw right now in basically the Atlantic, Hurricane Melissa. We are having 3 cyclones originating near the equator in the Bay of Bengal and the Arabian Sea region simultaneously. This is all what? This global boiling is going to result into climatic extremities. This is going to result into what? This is result into climatic extremities. We call them as what? We call them as climatic tipping points. So this is where now you incorporate current affairs into your concepts. So as the world warms beyond 1.5 degrees Celsius, so the average is now 1.5, but we are slowly moving towards this 2 degrees Celsius mark. So some of the climate tipping points have been reached. Now, What are those climate tipping points that have been reached? So I just shared that article on my group too. If I just give you a good AI summary of it, let me just open it up. See, climatic tipping points which we have achieved right now because of this 1.5 degree Celsius mark. Scientists say the world has crossed its first climate tipping point, coral reefs. Warm water corals are experiencing irreversible damage from heat, acidification, overfishing, and pollution. 80% of the coral reefs have faced unprecedented heat waves. So coral reefs, they are very vulnerable to the sea surface temperature. Once it crosses 27 degrees Celsius mark, the coral reefs, they are bleached beyond comprehension. So entire coral reef starts turning white. You all know that the coral reefs are having a symbiotic relationship with a marine algae called as zooxanthellae. So the zooxanthellae algae is being pushed out, the photosynthesis is stopped, corals start losing their color, and the marine life is no more attracted towards it. Coral reefs have one of the lowest temperature thresholds among the climatic tipping points. Loss of reefs threatens fisheries and coastal protection. Tipping points are self perpetuating, hard to reverse changes. There are up to 25 major climate tipping points, including Amazon dieback and polar ice cap melt. The Amazon rainforest tipping point may occur at just 1.5 degrees Celsius warning. Tipping point in the sense that the trees over there can stop doing photosynthesis. The Atlantic nodal circulation below 2-degree warming with global consequences. Planet predicted to cross 1.5 degree warming threshold within 5 years, increasing extreme weather and food water stress. Planetary boundaries and solutions. So 7 of the 9 boundaries have already been crossed, threatening Earth's habitability. Positive tipping points like rapid adoption of green tech are emerging but need global acceleration. So now, whenever you are preparing this topic, whenever you are preparing the structure, or rather I say composition, I have not yet tapped into the structure, I have taught just into the composition. Are identified places on Earth? Yes, Ayushi. So you are having 25 such tipping points. The first one is basically coral reefs, because coral reefs are the rainforest of the oceans. So whenever now we are preparing this topic, you have to interlink what? You have to interlink climate tipping points with this. Ocean water acidification, the dieback of the Amazon, the dieback of the boreal rainforest, the melting of the permafrost, increasing cyclonic activity, migration patterns of the animals changing. And more so, when I'm talking about this, we also need to understand and appreciate that these tipping points will have a long lasting impact on human economy too. Fisheries dwindling, then basically along with that, if you are having climatic extremities, infrastructure loss, loss of power, spread of diseases, new epidemics, and most importantly, climate refugees. So see, just in one point, I have elaborated 5 different dimensions to each and every one of you. So this is what success in prelims is about, guys. If you really want to score well in prelims, you need to understand this point very, very carefully. Now, if I'm talking about how you should understand the structure of atmosphere, see, to understand structure of atmosphere, we can basically understand it to 3 ways: the density based stratification, the temperature based, and basically based on the relative mixing up of gases. Am I holding atmosphere in between my hands? You will say yes, I am holding, because the air behaves like a well unified entity of gas. So here, no gases are able to segregate out on the basis of their respective atomic or molecular weights. Here you are not able to see nitrogen, oxygen all basically segregating out. Here what you are seeing is unified entity of air. So if I'm talking about basically the density based stratification of atmosphere. So density based meaning that at a height of around, let's say, 5.6 kilometers, approximately 50% of the atmosphere is rarefied. At a height of around 16 kilometers, 90%, and at a height of around 48 kilometers, 99.9% of the atmosphere is over. It is rarefied. the layers below are more compressed as we move up. Basically, the atmosphere becomes more and more rarefied. See, this does not mean that at this particular height, at a height of around 5.6 kilometer, if we are finding 78%, so let's say at the surface we are finding 78% nitrogen, and on the surface we are finding 21% of oxygen. This does not mean that if we are moving up, this percentage is decreasing. No, this percentage is constant. At a height of around 48 kilometers too, you will still be finding 78% nitrogen and 21% oxygen. The percentage proportion of gases in the atmosphere is fixed. What is going to vary is the absolute amount. What is going to vary is their absolute amount. So this can be asked as a FYQ now. So if I'm taking you to the summit of Mount Everest, will the nitrogen be 78%? Will the oxygen be 20%? The answer is yes. The atmosphere has rarefied. Air is still there. So the percentage proportion of gases which make up the air is same. Otherwise, the composition of air will start differing if this basically starts to differ. So this is very, very important. If I'm talking about the temperature based stratification, so in temperature based stratification, we have how many layers of atmosphere? So this is the equator, 0 degree. This is 90-degree north and south, the poles. The first layer we have the troposphere. Then the next layer we have the stratosphere. Then after that we have the next layer as mesosphere. And then the last layer it is referred to as the thermosphere, right? So the height of troposphere at the poles is 6 to 8. At equator it is around 16 to 18 kilometers. So this is height in kilometers out there. The stratosphere is still 50 kilometers, mesosphere is still 80, and thermosphere above. Is exosphere a distinct layer of the atmosphere? The answer is no. Exosphere is not a distinct layer of the atmosphere. It is that layer where atmosphere merges imperceptibly with the outer space. So, in troposphere, with increase in height, the temperature decreases. Why so? Because bulk of the greenhouse gases will be at the surface. As we move up, the temperature is bound to decrease. So this is referred to as normal lapse rate. Is the normal lapse rate same everywhere? If I'm taking it to the surface and if I'm taking it to the summit of Mount Everest, the normal lapse rate is going to vary. It is going to vary with seasons, it is going to vary with altitudes, it is going to vary with day and night. So troposphere will exhibit variations in NLR. So as it exhibits variations in normal lapse rate, the heat trapping will vary. Heat trapping will vary means this will somewhere the air will rise up abruptly, somewhere the air will be subdued. Pressure difference, temperature difference. So that is why if I'm talking about troposphere, troposphere will be referred to as which layer? It will be referred to as the weather layer. If we are talking about equator, all of us know at the equator the insolation of the sun is almost perpendicular. So as the insolation is perpendicular, so here the vertical convection is very high. Therefore, the troposphere is pushed up, and hence the temperature over here is minus 80 degree, whereas the temperature at the poles is barely minus 50 degree. In the stratosphere between 20 to 30 kilometers, we have ozone, which is a very important greenhouse gas. This is able to trap up the ultraviolet radiation. So stratosphere is basically heated from above, whereas troposphere will be heated from where? It will be heated from below. That is why we are having with increase in height the temperature changing, because this is heated from below. The outgoing terrestrial radiation of Earth is being trapped, and as the CO2, as the greenhouse gases are more concentrated near the surface, here the heat trapping will be more. Above, the heat trapping will be less. In stratosphere, because of the ultraviolet radiation, the ozone is able to trap heat. With increase in height, the temperatures are bound to increase. In mesosphere, again the reverse trend. With increase in height, temperatures will fall, because here we don't have any gas to basically absorb the heat. Then in thermosphere, with increase in height, again the temperature increases. But what happens beyond 80 kilometers? Is the air able to hold its composition? The answer is no. This is where we are finding brunt of the insolation coming, approximately 1360 watt per meter square. So the individual gases in the air now start segregating out on the basis of their respective atomic or molecular weights. So nitrogen segregates out, diatomic oxygen segregate out, atomic oxygen starts segregating out. So here the air is no more single unified entity of gas, rather in between 80 to 100 kilometers, this is where we find maximum concentration of ions. This is referred to as ionosphere. The ions do go till a height of around 250 to 60 kilometers. They also go till a height of around 300 kilometers, but the concentration of ions is maximum between 80 to 100 kilometers. This is capable of reflecting back the radio waves, helping in satellite communication. Now, the recent current affairs which you are seeing since yesterday, sunspot cycle. So the nuclear fusion on the sun is not uniform throughout its surface. Somewhere the reaction is very high, somewhere the reaction is very slow. So sun has got some bright spots, some has got some dark spots. The solar cycle peaks every 11 years. Peaks in the sense that, sorry, my bad, the solar cycle has basically a periodicity of 11 years. So after 11 years, it has a hard reset. It peaks in between 5 to 6 years. So it begins, it peaks and it goes down, and after 11 years it resets. The last solar cycle started in 2019 and 20. It is peaking in 2024 and 2025. So when the solar cycle peaks, we have the coronal mass ejection. Coronal mass ejection meaning you are having solar gusts, solar winds in the form of neutrinos coming. They will start reacting with the ions. When they start reacting with the ions, you will be having formation of what, guys? Will be having formation of, you will be having the formation of auroras. So recently you saw auroras as far as 30 degrees north. Why? Because this is the year when the solar maxima is peaking. So see the bright colored, so blue, purple, green, pink. Why? So ionized molecular nitrogen up to a height of 96, excited atomic oxygen at lower altitudes up to 241, then excited atomic oxygen. So this is atomic oxygen at low, this is atomic oxygen at high altitudes above 150 miles or above 241 kilometers. So up to 300 kilometers too. So this is molecular nitrogen, this is atomic oxygen, this is also atomic oxygen, low and high altitudes. So why is this? Because beyond 80 kilometers, air is not capable of withholding its chemical composition. The individual gases start segregating out there on the basis of their respective atomic or molecular weights. So the auroras being seen now, the Airbus calling the Airbus A320s. Why? Because of the solar maxima or the solar constant increasing because of high coronal mass ejection. So these are the current affairs which all of you have to interlink when to do the structure and composition of the atmosphere. Okay, so that's it for today. So in the next class, I'll be zoning on the temperature and the pressure patterns of climatology, and I will be giving you a good hindsight of the past 5 years of papers so that the PYQs are also revised, plus you will able to follow the current trends and what can be targeted in the future year questions. Those of you are watching me live right now, Ayush, Satish, Kanwar ma'am, is this fruitful to everybody? That is what I'm asking, because I don't believe in just opening up the PYQs and solving them for you. I believe in teaching you the stuff. I believe in giving you the right hindsight. So comments are always welcome. uh, Feedback is always welcome, but constructive, not destructive. Okay, so do not forget to follow me on Telegram. My official handle is CSC with PM. We'll meet every alternate Saturday like this, and we'll try to cover up as many PYQs as possible before the prelims of next year, along with the concepts. Some lecture of the concept map series. Okay, good. Chalo. So thank you everybody. I will now meet you all on Monday. So we'll start off with the Geography through Maps version 2.0, South America part 2, and then we will continue the series. Okay. So until next time, until the next great adventure, Tata Baba, adios amigos. Please keep on working hard. Please keep on smiling, because that is the ultimate crux of life. Okay. Thank you everybody. Take care. Bye bye.